Now let's move on to the next topic, file pointer. Okay, we'll just check this. Okay, first things first, what do you mean by file pointer? File pointer is any file, be it for reading, be it for writing, there should be a point from which the reading will take place. There should be a point or a location where the writing will take place. So all the files, they will keep track of the pointer or the reference. Or you could imagine something like arrow, which will, keep pointing at certain location. So at this particular location, the reading will take place or writing will take place. So these references or these indicators are what you mean by file pointers. When you read a file, you get to see the content of the entire file starting from the first character. So that means the file pointer by default would be pointing to the first character. When you want to append some information using the file mode of A, the new information will not be added at the beginning. Rather, they'll be added at the end of the old file. So it means, the file pointer by default must be pointing at the end of the old file. So based on the file modes chosen, the file pointers will be accordingly adjusted or adapted. So that's the definition of the file pointer. So how does this work is whenever reading operation takes place, whenever writing operation takes place, these pointers, they will be fixed at certain places. And then each time you carry out reading operation, every time you carry out writing operation, these file pointers will start to advance based on the characters or bytes, based on line by line, and this will be dependent on the kind of functions that you're using. For example, if you have information like okay, this should be a good example. I have a file by the name of ipl.txt. I open this, the file pointer will point at the first character. The moment I run this read 1, the first character, the first byte will be read and the pointer will now point to the next character. The question is, why did the file pointer advances by just 1 byte? Because it all depends on the kind of function that you're using. And then just in case if I have 2 here, M and U will be read and the file pointer will now jump to the third character, which is M. So this is what you mean by the file pointer. The file pointer is really very important. As you can, look at this slide. These are some of the file modes. I just want you to focus on the first one, R, because we are not yet done with the R plus RB, RB plus R plus B. These file modes, concern with the second kind of file by the name of binary files. So it's a common sense that file pointer would be pointing at the first character. The moment you use the file mode of R and then run the program, you get to see the content starting from the first character. So it means the file pointer, would be pointing at the first character of the file. And then same is the case with W. W file mode will allow us to create a new file if it doesn't exist. If it does exist, it will truncate and overwrite the old file with a new one. So it's a common sense, that the file pointer would again be pointing at the beginning of the file. Now there is this exception with the append. The new content will be added at the end of the old file, which means in the case of append file mode, the file pointer will be pointing at the end of the old file, so that the new file would be added at the end of the old file. So this is, the relationship between the file pointer and the file mode. Now let's try to understand a little bit on other kinds of file mode. We'll just go to the first slide. Okay, look at this. The first column is text file mode. The second one is binary file mode. Now this will be the altogether another, the story which will follow soon, perhaps in the next video. So I want everybody to skip this for the moment, and then let's focus on the text file mode, because we are dealing with just text files. You have R, W, A, R plus, W plus, A plus. I'm sure everybody must be now, familiar with these three file modes. R, just reading. W, just for writing sake. You need to watch out for this. If the old file exists, the Python will truncate and replace. But if there is no existing file, it will create a new one. What happens with A is, if the file does not exist, it will create a new one. This is the commonality, that's being shared with W. But the difference is, if there is an existing file, the new content will be added onto the old file, in the old file. Now let's focus on this, R+. This is solely for reading, solely for writing, solely for writing or appending. There are situations where you would like to perform reading as well as writing with the same file simultaneously. So in which case we have to use three more variations of file modes. The first one is R+, the second one is W+, and the third one is A+. We'll keep it very simple. Don't focus on this. Okay, I want everybody to focus on my explanation. R+. I'll not show you the demonstration of all three remaining file modes, because that will consume a lot of time. But just to let you feel a little more comfortable, I'll be showcasing one program which will help us to understand one of these three file modes. R+. In R+, what happens is it will support both reading as well as writing. Alright, so for this, file must exist, because the file mode says R+, right? So the main purpose of R+ is for reading purpose. So it's a sheer common sense that file must exist. If the file doesn't exist, the Python will immediately report an error. Okay, so the file must exist. Now let's say the file exists. I'm focusing on this. I'm focusing on R+. Let's say a file exists. So no problem with the reading operation. What happens with the writing operation? So where and how will the writing operation take place? Now let's say I have this file by the name of source, which has Leo, and then followed by Nay and then Frankie. Now the one important question is, where is the file pointer? How I wish you could answer back. But let's say where will the file pointer be pointing at? The file pointer will be pointing at the beginning of the file. It points to the L, not this, sorry. Okay, we'll just go and open the source. The file pointer will be pointing at L. Let's say I carry out the writing operation. The writing operation is supported by the R+. So if I write something like ABC, ABC will replace LEO. ABC, if written, will replace the LEO. The question is, why will it not be added after Frankie? Because for the sake of reading, the file pointer should always be pointing to the first character of the file. We'll try to write a program for this. even though it's not required, but in order to let you feel much more comfortable. Okay, let's open the file handle and then tie it to C:/ followed by temp. Okay, \temp / followed by source. Okay, there you go, source.txt, and then the file mode is R+. The file mode is R+. All right. So if you want to read it, it's simple. So I'll not write the information based on reading. So let's try to write ABC into it. So it's going to be fh.write and then followed by ABC, and then finally fh.close. All right. So apart from R+ supporting the reading operation, it will also support the writing operation. So the question is, how will it behave? We'll save the file and then let's run it. Okay, everything looks good. Let's run it and then check the content of source. As you can see, Leo has been replaced by ABC. Again, since the file mode is R+, the cursor will go back to the first character. So the main focus is on the reading. Just in case, if you want to make some modification to this program, such that the writing operation will take place at the end, can you think of a way out? We can have additional statement like fh dot or line equals fh dot read lines. When I do this, now let's say I would like to def or I would like to write Leo. I want Leo at any cost. Okay, Leo being my favorite. Okay, jokes apart. If I do this, if I add this additional statement, read lines, hopefully you remember, it's a input, it's a reading function which will read the entire lines, as a result of which the file pointer will now be pointing at the end of the file. And once the file pointer, points at the end of the file, and then you try to write Leo, even though it's not there in the text, but I'm just trying. I've tried earlier, it seems to be working fine. Let's see whether it works here, and then run it, and then let's go and check. Open this. Bingo, Leo has now been written at the end of the file. All right, so I hope you have understood the program. If not, I'll briefly tell you once again. R+ will support the reading operation. It will also support the writing operation as evident in my example. But the question is, where will the writing take place? It will take place right at the start. The reason is, for reading, the file pointer must be pointing at the first character. When you want to read something, you certainly wouldn't like to read from the second paragraph. Same is the case with watching a movie. How about missing out completely, over the first half and then starting the movie from the second half? That's certainly not a good idea. So likewise, the file pointer will always be pointing at the first character. But just in case, if you want to make the modification to this program such that the addition will take place at the end, why don't you use this statement? Okay, so let's go back and deal with the other two. In W+, again, it supports reading, it supports writing. If the file doesn't exist, it creates a new one. If it does exist, as usual, the old content will be truncated, it'll be replaced by the new one. All right, so, and then you could also perform the reading operation. It's pretty simple. And then in A+, again, if the file doesn't exist, the new file will be created. If the file does exist, it will not be truncated or replaced, rather appending will take place. I've explained to you enough with how appending, works. So The difference between the first three and the later three is these three are solely meant for only one operation, either reading, writing, or appending, but the later three will support both reading as well as writing, but the only difference is the way the reading, the way the writing will behave, and it will also be differentiated by the behavior of the file pointers. So if you want, you could try out on the system how W plus behaves, how A plus behave. It's a wonderful idea to be trying off your own, to be jumping little off the textbook and then get on with a practice session. It will enhance your programming skill to a great length. So the final topic that I would like to discuss is the absolute and the relative file path. The absolute and the relative file path. Okay, where is it? It should be the last topic for today's lesson. Okay, there you go. Absolute and relative. Again, I'll show you through the practical demonstration. Otherwise, if I say something like, this is absolute, that is relative, perhaps, this should do the work, but again, there will be something amiss for sure. First things first, what do you mean by absolute? Absolute is something which is identifiable by itself. You don't need any other supporting elements to be defining certain entity. That's the general meaning. Relative means you cannot understand the entity of its own. The definition of the term has to be based on something else. I'm sure you must have heard, these two terms often in various fields of technology and religion also, especially in Buddhist philosophy. So, okay, now let's say I write a statement of import OS. Let me check the time. Okay, it's 57 minutes already. Import OS, and then I would like to print os.get. These are function, and this is nothing but function. CWD means current working directory. All right, and then when I press enter, I see a path here. I see one lengthy path starting with the drive label. This is what we mean by drive label. The hard disk, a quick recall on basic. The hard disk is divided into the partitions. Each partition is identified by the label, the drive label of C, D, E, F. One student, happened to ask me this question, sir, I'm not able to find the C drive, D drive on my computer. And then funnily, I realized that she happens to be using the Mac. And I didn't know until date, that the drives in Mac computers, do not use the drive labels of C, D, E, but rather they go by the drive names. So this is the drive label, and then these are the directory or the folder. Drive label, the directory or the folder. Folder, all these are nothing but folders. All right, folders, subfolders, it will go on and on. So now let's say I go back to one of the files, and then I check the address. I check the address. You see this, or if I click on this, this is an example of the absolute address of source. Absolute address means the complete path starting from the drive label until the file itself. The complete path of the address is what we mean by absolute path, and this will never ever change. C temp source will be the absolute, or will remain the same path always for the file itself. So this is pretty simple. But what do you mean by relative is the address will be based on something else. Like I showed you this particular address. This address is the address of current working directory. Current working directory is the environment where the Python is operating. For example, what is my current directory? In the bedroom of my, the staff quarter, this is the current working directory. All right. So, this particular file path ultimately points to the folder or the environment from which the Python is operating as a programming language. Okay. So now this particular, the Python, the path could be used in relative sense. I'll try to show you. Now let's say I'll just copy this and then paste it here. If I paste this and then press enter, there you go. Now these are in fact, this is the environment from where the Python is operating. All right. Now let's try to understand, how do you refer to a relative, the path. Let's say I have a file by the name of data. I've tried this yesterday. So now this particular file is stored in the current working directory or the current folder from which the Python is operating as a programming language. All right. So if I want to address to this, say if I want to print Leo, Nay, Frankie from the file name of data, don't you think it would be troublesome for us to be mentioning the entire path of the file name? The absolute file path, would sound really crazy. There are just too many, the folders and the subfolders in the path itself. Now that's when the relative file path comes to our rescue. We'll not have to specify all these. Now let's say for a change, I'll change it to PK followed by Lewis, or I'll just write Martinez. I'm looking forward to this player. Okay, PK and Martinez. All right. I would like to print PK. So I go back to my Python script and then I'll get rid of this. Now this time I don't need to make use of the absolute file path. Rather, I'll be using a single dot and then / followed by the name of the file. The name of the file is data.txt. All right. So this particular dot indicates the current working directory. The current working directory. Say I read it, line equals fh dot read line, or if I want to read all the names, I could do with read with no specification with the argument, and then I'll just print it and then followed by line. All right, we'll save this and then run it. Hopefully it works. Okay, there you go. PK, Martinez, Leo, Nay, and Frankie. This is what you mean by relative path. So this dot indicates the current working directory. Tomorrow, I would like to do this program on some other laptop. All right. I never need to worry about the addresses starting from the C and then moving on, and then finally, the last folder in which the data.txt, would have been stored. I don't need to worry at all because the dot will blindly point to the current working directory of your Python, be it on any laptop or the desktop computers. So this data.txt, can you ever say that it's, it has the absolute location or it has the absolute address? No. The address of data.txt will be dependent on the current working directory. Wherever be it, the dot will help us to locate it. So, that's the definition of relative path. Let's say I'll make some modification. I go back and then I have another folder by the name of, let's say I'll have another folder, new, and then folder, and then I'll just write here, okay, what should I write? ABC. All right, and then I open this ABC, and then I'll create a new folder. All right, new folder, and then followed by, or not new folder, I need a text file. Go to new, and then text by the name of, this time it'll be data1. I open this, I'll write Louis, and then Ter Stegen, that's it, and then I'll save this, close it, and then get back to the main program. This time the name of the file is data1. If I run the program, will it work? Obviously it will not work, because data1, not data1, is it data1? Okay, let's go, right, it's data1. So data1 is in which folder? It is in the folder of ABC. If you just leave it like this, data1 is a file which is stored in the current working directory. But in the current working directory, we don't have the file by the name of data1, right? So if you want to refer to data1, in the current working directory, we have another folder by the name of ABC, right? So data1 is stored in ABC folder, and this ABC folder is indeed in the current working directory. Now let's run this. Okay, where is my shell? Run this. Okay, there you go, Louis and Ter. Okay, for the final variation, let's go one folder up. The last folder is Python 37-32. Let's go to Python, one folder up, the tree, and then I'll create a file by the name of data2, and then I'll enter. Okay, enough of the Barcelona footballers, just to make the Real Madrid fans feel a little better. I'll have Benzema followed by, okay, whoever, and then save it and then close it. Now this time the data2 folder, is it in the current working directory? The answer is no. Rather it is, can I say something like this? Data2 is a file which is stored in the parent folder of current working directory. Can I say so? Data2 is stored in Python, which is the parent folder of Python 37-32. This is the current working directory, and this is the parent folder of the current working directory. If you want to print the content of data2, which is in the parent folder of current working directory, you have to use two dot symbols. I repeat, two dot symbols. So let's go back and check. All right, so I'll change this to data2. I'll get rid of this. Okay, if I leave it like this, it means data2 should be present in current working directory, which is a mistake. So if I have two dot here, data2 is now stored in the parent folder of current working directory, which means data2 is stored in the Python, which is the parent folder of the current working directory, right? So if we run it, and if I get to see the Benzema and whoever Vinicius, then the program, is correct. There you go, Benzema and win. So in short, you have two kinds of paths. Absolute, it's straight and simple. If you have the complete path starting from the drive label till the last folder, that's the definition of absolute path. The address has nothing to be based on any other factors as such. Relative address is the address, which is dependent, which is relative to the current working directory. Okay, So if it's a single dot, you are referring to current working directory. If you have two dots, you are referring to the parent folder of the current working directory. Well, with this, we have come to the end of the first half. Should I say first half? No, in fact, this year there were quite a bit of upgrades in the curriculum of class 12. So I could safely say that with this, with the end of the third video lesson, I could safely say that we have come to the end of the first of the 3 parts of this particular chapter. So we're just done with 1/3 of this chapter, and then the next part will be on the operation based on binary files, and then finally we'll have the operations based on CSV, comma separated values. So it's almost close to 1 hour 10 minutes, so I better stop here. So as usual, I request everybody to watch the video in its entirety. Make sure that you have completely understood the concept. Now this is what I like about the online video. You could summon the teacher wherever you are, whenever you want. Even in the middle of the night you could do so. All right, so please study hard. Always look at the brighter sides of online teaching. If you just fretting over the disadvantages of the online, you will have nothing to gain. Okay, so please study hard, study well, and I wish you all the best. And then until next time, please take very good care of yourself. Thank you very much. Thank you.